Hello everyone and welcome back to my channel. This is the A+ Tutor. Today we're going over linear functions and their graphs. All a linear function is a line on the coordinate plane. So whenever you see a line going across your coordinate plane, that is a linear function. There are three ways that we'll typically find our equation for our linear function. This may either be in standard form, which is ax plus by equals c, slope-intercept form, which is y equals mx plus b, and point slope form, which is y minus y1 equals m times x minus x1. When graphing and working with linear functions, typically the first thing we'll need to find is the slope of our function. The slope is just how fast our function is increasing or decreasing. So we can find slope when we're looking at a graph by using rise over run. We use m to note the slope. So whenever you see m in your linear function, that typically means the slope of your function. We find 2 points on our graph, so we want 2 places where we can read whole numbers for our points. For example, on this graph, we see a point at 0, 1 and a point at 1, 3, and in between those, we don't really know what the x or y value is. So we want to find places that cross our little boxes in our coordinate plane. For this line here, we will rise 2, so we go up 2 units, and run 1, we run to the right 1. Anytime we go up, it's positive, down is negative, right is positive, and left is negative, so that'll be important for identifying our slope. But with our rise over run being 2 over 1, our slope is just 2. You don't need the graph of a line in order to find the slope. If you have 2 points from your line, you're able to figure out what your slope is. So let's say we have 2 points, x1, y1, and x2, y2. The formula for our slope will be y2 minus y1 over x2 minus x1. For example, let's take 2 points on this line, like 0, 1, and 1, 3. 0 is x1, 1 is y1, 1 is x2, and 3 is y2. So if we plug that into our slope function, we get m equals 3 minus 1 over 1 minus 0, which is 2 over 1, and that's equal to 2. So we see whether we find our slope using rise over run or using our slope formula, we get the same slope. Let's take some examples finding our slope. So first we have this graph, and remember, given a graph, we can use rise over run. So since our slope is equal to rise over run, let's find a starting point. Looks like we rise 3 units and run 2 units, which means our slope is 3 over 2. We can also go the opposite way just to verify that this works, and when we are graphing our lines, going the opposite way helps us find another point on our graph. So if we rise down 3, that means we're going negative 3, and running to the left 2, that's negative 2. We have negative 3 over negative 2, which is 3 over 2. That's the exact same as the slope that we just found, which means our slope is 3 over 2. Now let's look at the slope between 2 points. We have the points 3, 4, and negative 4, negative 5. Keeping in mind our slope formula is y2 minus y1 over x2 minus x1. Labeling our points, our 3 is x1, our 4 is y1, -4 is x2, and -5 is y2. Plugging that into our slope formula gives us m equals -5 minus 4 over -4 minus 3. -5 minus 4 is -9. -4 minus 3 is -7. So this is equal to 9 over 7. And the slope of our line between these 2 points would be 9 over 7. Let's look at another graph and find the slope from the graph. We have this graph here. Let's identify a point on this line. We want to get to the next point. So the way that we're going to do that is we're going to rise 5 units. We need to go 5 units up and run 3 units to the left. That means our rise over run is equal to 5 over -3, and our slope is -5 over 3. Now let's look at 2 points. Keeping in mind our slope formula is y2 minus y1 over x2 minus x1. Given the points 6, 2 and -9, 7, x1 is 6, y1 is 2, x2 is -9, and y2 is 7. Let's plug those into our slope formula. We get 7 minus 2 over -9 minus 6. 7 minus 2 is 5, and -9 minus 6 is -15. 5 over -15 can be simplified because both 5 and 15 are divisible by 5. So let's simplify this fraction. 5 divided by 5 would leave us with 1, and 15 divided by 5 leaves us with 3. This means our slope for the line between these 2 points is -1 over 3. Let's take another line. Our slope, when we're finding the slope from a line, is rise over run. So let's pick a point. From this point, we're going to rise down 1 unit and run to the right 1 unit. So that gives us -1 over 1, or just -1. And again, finding the slope between 2 points. Our slope formula is y2 minus y1 over x2 minus x1. So, with the points 11, -18, and -1, -7, our x1 is 11, y1 -18, x2 is -1, and y2 is -7. Plugging those into our slope formula gives us -7 minus -18 over -1 minus 11. -7 minus -18 is the same as -7 plus 18. Anytime we have minus a negative, we're going to add. Then -1 minus 11 is equal to -12. -7 plus 18 is 11. So we have 11 over -12, which is -11 over 12 for our slope. As I mentioned earlier, we do have 3 different equations for our linear functions. The first is called standard form, which is ax plus by equals c. For example, 2x plus 3y equals 6. Next, we have slope-intercept form. This is y equals mx plus b. An example of this is y equals negative 2x plus 1. The two additional variables we have outside of x and y are in our name, our slope and our intercept, specifically our y-intercept, and I'll get more into this a little bit later in the video. Last, we have our point-slope form, and point-slope form is y minus y1 equals m times x minus x1. An example of this may be y minus 4 equals 1/2 x plus 2. Again, the additional variables outside of x and y we have in our formula are in the name. It's an additional point and a slope. Also, we typically use point-slope form to find the equation in our slope-intercept form, but it's important to be able to identify what each of these values represents so that if you are given an equation in point-slope form, you could potentially graph that or identify a point or identify the slope of that function. Let's look at some examples of graphing linear functions in standard form. The way that we graph our functions in standard form is we will find our x and y intercepts. We do this by setting x equal to 0 to find the y-intercept and set y equal to 0 to find the x-intercept. Let's look at one of these examples. We have x plus y equals negative 2. If we let x equal 0, we want to put 0 anywhere there's an x. That gives us 0 plus y equals negative 2, or y equals negative 2. This means our y-intercept is negative 2, and we have a point at 0, negative 2. Let's do the opposite and find the x-intercept. Let's let y equal 0 and plug in 0 anywhere there's a y in our function. So x plus 0 equals negative 2, and again, x equals negative 2. So just like our y-intercept was negative 2, our x-intercept in this case is also negative 2, and we have a point at negative 2, 0. So when we graph this on the line, we can plot those 2 points and just draw the line between those 2 points. So whenever we have functions in standard form, we can always graph them using our x and y intercepts. Let's start with our y-intercept since we found that first. Our y-intercept is at 0, negative 2. The y-axis is the vertical axis, so we're going to go down 2 units and place a point at 0, negative 2. Next, let's plot our x-intercept. X is going to be the horizontal axis, so we're going to move 2 units to the left and have a point at negative 2, 0. So now that we see our x and y intercepts, we can graph the line by drawing a line through these 2 points that extends past both points. As we can see here, by using our intercepts, we're able to find the line that represents our function x plus y equals negative 2. Next, let's look at the linear function 2x minus 5y equals 5. Let's start with our y-intercept, which means we're going to let x equal 0. So, plugging in 0 for x gives us 2 times 0 minus 5y equals 5. Or 0 minus 5y equals 5, so negative 5y equals 5. Divide both sides by negative 5, and you get y equals negative 1. So our y-intercept is at 0, negative 1. Now let's find our x-intercept. Set y equal to 0, so plugging in 0 for y gives us 2x minus 5 times 0 equals 5, or 2x minus 0 equals 5. So 2x equals 5, divide both sides by 2, and x equals 5 over 2. So we have an x-intercept at 5 over 2, 0. So now let's graph our intercepts. We have a point at 0, negative 1, we need to know where 5/2 is on our graph, and 5/2 is equal to 2.5. So we know we're halfway between 2 and 3. And a point at 2.50. And here's what that line looks like. Our next example is 4x minus 3y equals 6. Let's start with our y-intercept. So we're going to let x equal 0. Plugging in 0 for x gives us 4 times 0 minus 3y equals 6. 4 times 0 is 0, so 0 minus 3y equals 6, or negative 3y equals 6. Divide both sides by negative 3, and that gives you y equals negative 2. This means our y-intercept is at 0, negative 2. Now let's find our x-intercept. So we'll let y equal 0. Plugging in 0 for y gives us 4x minus 3 times 0 equals 6, or 4x minus 0 equals 6. 4x equals 6. Divide both sides by 4. When we divide 6 by 4, this does not divide evenly, so we need to simplify this fraction. 2 goes into both 6 and 4. We can divide both of these terms by 2. 6 divided by 2 is 3, and 4 divided by 2 is 2. So our x is equal to 3/2, and our x-intercept is at 3/2, 0. 3/2 is equivalent to 1.5, so our y will be at negative 2, and our x will be in between 1 and 2 at 1.5. Here's what this line looks like. Last, let's take the function 3x plus 4y equals negative 12. Starting with our y-intercept, let's let x equal 0. So we have 3 times 0 plus 4y equals negative 12. 0 plus 4y equals negative 12. So 4y equals negative 12. When we divide both sides by 4, we get y equals negative 3. So our y-intercept is at 0, negative 3. Now let's find our x-intercept by setting y equal to 0. So 3x plus 4 times 0 equals negative 12, or 3x plus 0 equals negative 12. So 3x equals negative 12. Divide both sides by 3, and you get x equals negative 4. Our x-intercept is at negative 4, 0. Plot these both on our graph and connect our line so we can see this function. Now, let's look at graphing linear functions in slope-intercept form. So as I mentioned earlier, our slope-intercept form, our variables inside our equation are just that, the slope and the intercept. So in slope-intercept form, m is your slope and b is your y-intercept for your function. By just plotting your y-intercept and using your slope to find 2 new points, you can graph your line. So let's take a look at this. We have y equals negative x plus 4. Our slope is negative 1, so we have a negative in front of our x, which means there's an imaginary 1 there. So our slope itself, our m term, is negative 1. And our b is 4, which means we have a y-intercept at 0, 4. So if we plot our y-intercept, plot that first point, and then use our slope, keeping in mind slope is rise over run. Let's rise 1, positive 1, and run to the left 1, or we can rise -1, go down 1, and go to the right 1. We actually want to do both of these so that we can get 3 points and be able to draw our line. When we're dealing with negative slopes, we just have to make either our rise or our run negative, not both. We want to think of that fraction, right? Rise over run. A negative over a positive is a negative number, or a positive over a negative is a negative number. However, negative over negative will not be a negative number. That will be a positive number. So we want to make sure we keep that negative by going rise up, run left, or rise down and run right. Next, we have y equals 2/3 x minus 2. Again, our m, or our slope, is going to be attached to our x. So our slope in this case is 2/3, and that represents your rise over run. Then -2 is our b, or our y-intercept. So we have our point at 0, -2. Let's plot 0, -2, and use our slope to find 2 more points. We can rise 2 and run 3, and then rise -2 and run -3. Here's what this line looks like. Our next line is y equals 4/5 x plus 2. Our slope is the number attached to our x. So our m is equal to 4/5, and this represents our rise over run. Our b is equal to 2. This means our y-intercept is at 0, 2. So let's plot our y-intercept and then use our slope to find the next point. So we'll rise 4 and run 5 units, go up 4 and to the right 5. And then we'll rise down 4, so we'll fall 4, so to speak. And we'll run to the left 5 units to give us another point. And connecting these dots gives us our line for this function. Last, we have y equals -1/2 x minus 2. So our slope, which is attached to our x, is -1/2, which means our rise over run is -1/2. Our b is -2, which means our y-intercept is at 0, -2. First, we'll plot that y-intercept and then use our slope to find 2 more points. So we can rise 1, +1, and run -2, that gives us our -1/2. Or we can rise -1, which means we'll go down 1 and run +2, which gives us our -1/2 as well. Connect those dots, and here's what that line looks like. I did mention we had a third equation, and that was our point-slope form. So let's talk about how we can use our point-slope form. We can use point-slope to find a linear function given a slope and a point. So remember, point-slope form is y minus y1 equals m times x minus x1. So let's say we're given that the slope, or our m, is equal to 2 and our point is 2, 5. We'll keep in mind all of our coordinates, any points that we're given, have an x and a y, which means our x1 is 2 and our y1 is 5. So all we need to do is plug this into our point-slope form and simplify and solve for just x and y as our variables. So our point-slope form is y minus y1 equals m times x minus x1. Plugging in these values will give us y minus 5, we're putting in our y1 here, equals 2, our slope, times x minus 2, our x1 value. Let's start to simplify. We'll start by distributing our 2 to our x and to our 2. Whenever we have a number in front of us out of parentheses, we have to distribute. So this gives us y minus 5 equals 2x minus 4. Now, to get y by itself, let's add 5 to both sides. So on the left side, we're just left with y. And on the right side, we have 2x plus 1. So our line has the equation y equals 2x plus 1. Next, let's say we're given m is equal to 4 over 3, and our point is negative 3, 0. So we know our m, and for our point, x1 is negative 3, and y1 is 0. So our point slope form is y minus y1 equals m times x minus x1. This means y minus 0 equals 4 over 3 times x minus negative 3. Whenever we have minus a negative, that turns into positive. So x minus negative 3 will become x plus 3. Also, since we have y minus 0, we can just write y since we're not adding or subtracting any value. Let's distribute our 4 over 3 to our x and to our 3. 4 over 3 times x is just 4 over 3x, but 4 over 3 times 3 is going to be 4, because when we multiply our fractions, we can cross-cancel anything that is the same. So since we have a 3 on the bottom and a 3 on top, we can cancel this, and we're just left with 4. So our final function in slope-intercept form is y equals 4/3 x plus 4. Next, we have m, or our slope, is equal to negative 1, and our point is negative 1, negative 2. This means x1 is negative 1 and y1 is negative 2. Plugging this into our point slope form gives us y minus negative 2 equals negative 1 times x minus negative 1. Whenever we have minus a negative, that will become a positive operation between the two numbers. This means our function becomes y plus 2 equals negative 1 times x plus 1. So let's distribute our negative 1 to our x and to our 1. And this gives us y plus 2 equals negative x minus 1. To get y by itself, let's subtract by 2 on both sides. And our final function in slope-intercept form is y equals negative x minus 3. Last, we have m, or our slope, is equal to 3 over 5. And our point is 1, negative 1. Let's identify our x1 and y1, which in this case, x1 is 1 and y1 is negative 1. So when we plug that into our point slope form, we get y minus negative 1 equals 3 over 5 times x minus 1. So minus a negative becomes a plus. That means on the left side, we get y plus 1 equals 3 over 5 times x minus 1. Let's distribute our 3 over 5 to our x and to our negative 1. So we get y plus 1 equals 3 over 5x minus 3 over 5. So when we subtract 1 from both sides, on the left side we're just left with y. But when we subtract it from the right side, we can think of it as subtracting 5 over 5, because that is the same as subtracting 1. 5 over 5 is equal to 1. And whenever we are adding or subtracting fractions, we want to work with common denominators. So in this case, our common denominator is 5, and 1 is equal to 5 over 5. So negative 3 over 5 minus 5 over 5 is going to give us negative 8 over 5. And our linear function then is y equals 3 over 5x minus 8 over 5. Now, let's say we're not given the slope outright and we need to find our linear function given 2 points. Well, if you remember at the very beginning of this lesson, the very first thing I talked about is finding slope with 2 points. So if we're just given 2 points, we are absolutely able to find the equation for our line. All we have to do is add one step to the process that we were taking before and find the slope. So step 1 is find our slope using our slope formula, which is y2 minus y1 over x2 minus x1. And then we plug in our slope and one of our points into our point slope formula. So let's see this in action. Say we have the points 0, 2, and 3, 5. So x1 is 0, y1 is 2, x2 is 3, and y2 is 5. So let's start by finding the slope. Our slope formula is y2 minus y1 over x2 minus x1. So we have 5 minus 2 over 3 minus 0. This gives us 3 over 3, which is equal to 1, so our slope is 1. Now we can use the slope to find our equation for our line. We want to pick one of our points, but regardless of whichever point we pick, we'll get the same value. So I'll show you how this works with both points. Using our point slope form, which is y minus y1 equals m times x minus x1, we will have either y minus 2 equals 1 times x minus 0, which means we plugged in our first point, or we may have y minus 5 equals 1 times x minus 3. I'll start by solving it with our first point, and then I'll show you that that is equal to what we get when we solve it with our second point. So you can always pick whichever point you want to use when you're finding your equation for your line. So in our first case, because we have x minus 0, we can drop that 0. So we have y minus 2 equals 1 times x. 1 times x is just x. So we'll add 2 to both sides, and our function becomes y equals x plus 2. Let's look at this using our other point. So we have y minus 5 equals 1 times x minus 3. If we distribute our 1, we get y minus 5 equals x minus 3. Add 5 to both sides. Negative 3 plus 5 is positive 2. This means we have y equals x plus 2. Let's look at another example of finding our equations of our lines this way. So we have the points 1, negative 1, and 4, negative 5. This means our x1 is 1, our y1 is negative 1, x2 is 4, and y2 is negative 5. So let's start by finding our slope. Our slope is y2 minus y1 over x2 minus x1. So this is going to be negative 5 minus negative 1 over 4 minus 1. Anytime we have minus a negative value, that becomes positive. So in reality, we have negative 5 plus 1 over 4 minus 1 is 3. So our slope is negative 5 plus 1 is negative 4 over 3, or negative 4/3. Now we can use our slope to find our equation for our line. Keeping in mind we're using point slope form, which is y minus y1 equals m times x minus x1. We're going to do this with both points so that we can see that they're always equivalent. We will have either y minus negative 1 equals negative 4/3 x minus 1, or y minus negative 5 equals negative 4/3 x minus 4. Let's start with the left side here. Y minus a negative is going to turn into a plus. So we have y plus 1 equals negative 4/3 x minus 1. Let's distribute our negative 4/3 to both our x and to our negative 1. So this means we have y plus 1 equals negative 4/3 x plus 4/3. And now let's subtract 1 from both sides. So when we subtract 1 from both sides, on the right side, we're subtracting 3/3. Whenever we're adding and subtracting fractions, we need to make sure we have common denominators, and our common denominator here is 3, so we're going to subtract 3/3. 4/3 minus 3/3 is 1/3, and our function is y equals negative 4/3 x plus 1/3. We'll see that this is true when we use our other point. So again, we have y minus negative 5 equals negative 4/3 times x minus 4. Minus a negative is plus, so we have y plus 5 equals negative 4/3 times x minus 4. Let's distribute our negative 4/3 to our x and to our negative 4. So we get y plus 5 equals negative 4/3 x plus 16/3. 4/3 times 4 is 16/3. So then we're going to subtract 5 from both sides. When we subtract 5, we're going to be subtracting 15/3 because 5 is equivalent to 15/3. And that gives us a common denominator. So we get 16/3 minus 15/3, which is 1/3. And our function is y equals negative 4/3 x plus 1/3. Next, the points we have are 5, 5, and negative 1, negative 1. So x1 is 5, y1 is 5, x2 is negative 1, and y2 is negative 1. To find our slope, we'll use y2 minus y1 over x2 minus x1. This becomes negative 1 minus 5 over negative 1 minus 5, which is negative 6 over negative 6, and that's equal to 1. So now that we know our slope, we can find our equation for our line using point-slope form, which is y minus y1 equals m times x minus x1. So plugging in our point, we get y minus 5 equals 1 times x minus 5, or y minus negative 1 is equal to 1 times x minus negative 1. Let's start with our left side. We'll distribute our 1 to our x and to our negative 5, so we get y minus 5 equals x minus 5. And when we add 5 to both sides, we get y equals x. Let's look at our right side. So minus a negative means we are going to add. So this means we have y plus 1 equals 1 times x plus 1 as well. Let's distribute our 1 to our x and to our 1. So we get y plus 1 equals x plus 1. Subtract 1 from both sides and we get y equals x. So our linear function between these 2 points is y equals x. For our last example, we have the points 4, negative 2, and negative 2, negative 5. So x1 is 4, y1 is negative 2, x2 is negative 2, and y2 is negative 5. Let's start by finding our slope. Our slope formula is y2 minus y1 over x2 minus x1. So this is equal to negative 5 minus negative 2 over negative 2 minus 4. Minus a negative will become a positive. So this means in our numerator, we have negative 5 plus 2 over negative 2 minus 4 is negative 6. Negative 5 plus 2 is negative 3 over negative 6. And this simplifies to 1/2. Our two negatives make a positive, and 3 over 6 simplifies to 1 over 2. So now let's use this to find our function. Point slope form is y minus y1 equals m times x minus x1. So we'll have y minus negative 2 equals 1/2 times x minus 4, or y minus -5 equals 1/2 x minus -2. Starting with our left side, we have y minus a negative will be plus, y plus 2 equals 1/2 times x minus 4. We'll distribute our 1/2 to both our x and our -4. So this gives us y plus 2 equals 1/2 x. 1/2 times 4 is 2, so 1/2 x minus 2. Let's get y by itself by subtracting 2 from both sides. So this gives us the function y equals 1/2 x minus 4. So now let's look at this with our other point. Minus a negative is always going to be a positive, so we can write this as y plus 5 equals 1/2 times x plus 2. We'll distribute our 1/2 to our x and to our 2, so we have y plus 5 equals 1/2 x plus 1. 1/2 times 2 is equal to 1. To get y by itself, subtract 5 from both sides. So our function is y equals 1/2 x minus 4. Thank you so much for watching. I hope you enjoyed and I hope you learned something. If you have any questions or comments, please leave them down below. You can also find me on Instagram and on Facebook at the A+ Tutor. I upload new videos every week. I'll see you next time.